some of you might know or might not know, matrices, they have little brackets around here. And if I put like the number 5 in here, this is called a 1 by 1 matrix, meaning it's one row by one column. What? What, John?
That's molarity matrix.
Oh, that means molarity? I don't know. Well, in math it means matrix. I don't know anything about science. Okay? If you have something that looks like this, where you have some numbers, and you have like a 2, -1, 0, and a 0, -2, 5, or something like this, this is called a 2 by 3 matrix because it's 2 rows by 3 columns, and so on. Okay. You also have, if they have this straight down like this, where you have like -1, 7, 8, 4, or something, that would be a what by what? 4 by 1. Okay. It always goes rows then columns, and this is also called a column matrix because it's just got columns.
There's not one 2 by 2.
One column. Oh, sorry. You're right. It's a 2 by 2.
No, it's 2 by 3. Separate.
Oh,
They're separate numbers.
sorry. It was meant to be a 2 by 3. Yeah, that looks like a 25 and it's iron. Okay, and then you can have a matrix. Yeah, that's basically what I don't feel like it. Okay. So you can have a matrix that looks like this, 1, 0, 4, something like that. That's a 1 by 4, and that's also just a row matrix because it's just got one row in it. Okay? So that's that. We're done. Not okay. So so if you have a system of equations, right? So I'm gonna try to write this without messing up too much. Oh, not a system. With system, they put brackets on. Okay. So if you have a system equation like we had in the last unit, x minus 4y, x minus 4y plus 3 or minus 3z equals 5. I'm just gonna make one. And 2x plus z equals -7, and x plus 2y equals 11, or something like that. Okay. This is a system of equations. So this is a system. That system can be expressed equivalently as an augmented matrix. Augmented matrix. And in this case, every place there's not a term, you put a 0 in the matrix. So augmented matrix. That can be expressed like this: 1, -4, -3, and then a 5 over here, and then a 2, then a 0 because there's no y term, and then a 1 for the coefficient of the z, and then a -7 over here, and then a 1, a 2, a 0 because there's no z term, and then 11 over here. And what they do over here is they put a dotted line over here. Okay? And these are the coefficients. What? Going too fast? Sorry, it's tilted. But it's hard to. So these are the coefficients, and these are the constants over here. So if I were to write this as 2 separate matrices, which you do when you actually solve this using matrix multiplying by inverse matrices, which we're not going to do yet, okay? -3 and 2, 0, 1, and 1, 2, 0, like that. This thing is called the coefficient matrix. Coefficient matrix. And this thing over here, like that, 5, -7, and 11 is called the constant matrix, because that's the right side of the equation. Okay? So when you're solving these systems, you want to write them in augmented form, and then you're going to do some operations on them to get them into what's called echelon form, and then you can do it further to get them into reduced row echelon form. But I'm not gonna do an example like that yet. Okay, so what's next? Elementary row operations. Oh, so the things you're allowed to do on matrices are just like the things you're allowed to do elementary row operations. You're allowed to do the same thing to a row as you can if you're solving a system of equations. So the three things you're allowed to do is, one, you're allowed to interchange two rows. Interchange two rows, which is a useful strategy sometimes. Two rows.
Does that include the constant?
What?
Does that include?
Yes, that's what I was going to talk about too in a second. Okay. And two, you're allowed to multiply a row or row by a non-zero constant. And three, you're allowed to add a multiple of one row to another. Okay? So those are the operations that, and multiplying and dividing, they're kind of used interchangeable, and adding and subtracting, kind of the same thing. So add a multiple of one row to another. And what Atai said is important is when you're doing these operations, just because the constants are over there on the right side, you can't forget to multiply those constants as well, right? So if you're multiplying the row, you have to multiply the entire row, including the constant. Got it? All right, so now I'm going to look at some of my notes. Where's that I stole from the book? Don't tell anyone. Okay? Gaussian elimination. We're not going to talk about that. Where's that first page of my notes go? What? Keep going. This. Okay? Row echelon form of a matrix. Can you see that?
No.
You can't? Now can you see it? Except it's hiding over that thing. I can make this smaller, I think. Move it somewhere. There. Okay? So this is in your book, but it says a matrix. Why write this all down? This is in your book. But a matrix in row echelon form has the following properties. And what you're trying to do when you solve a system, you try to get an equation, augmented matrix into this form, because then it's easy to solve. Okay? And so a matrix in row echelon form has the following properties. Any rows consisting entirely of zeros occur at the bottom of the matrix. Okay? So I'm going to show you some of these in a minute. Okay? So this one right here, where's this one? This one's okay, because then this one has all zeros. That's okay. But see how there's a row with all zeros in B? That's not in row echelon form. Okay? So this one's no good B over there. All right? Hey, go away. There we go. Okay? The other thing is for each row that does not consist entirely of zeros, the first non-zero entry is 1, called a leading 1. Leading 1. Hey, just like being in a show. You could be the leading 1. Okay? For two successive non-zero rows, the leading one in the higher row is further to the left than the leading one in the lower row. And finally, a matrix in row echelon form is in reduced. We're not going to worry about this yet, but it is in reduced, how to do this, but I'll show you an example. Reduced row echelon form, when every column that has a leading one has zeros in every position above and below its leading one. Okay? So, for example, here are some things that I stole out of your book. Is this one in row echelon form? This one is in row echelon form because all the leading ones and they're the first term of each row. Okay. B, we already said, is not in row echelon form because it's got a row of zeros. That row of zeros needs to be at the bottom. C, this is okay. Okay, even though this one is not in this position, this one is in a higher position than this one, right? So it kind of needs to go across like that, and so this one's okay. This one is okay, okay, because there's a row of zeros at the bottom, but that's okay. But it goes 1, 1, 1 like that. Is this one in row echelon form? Hello. What does this number have to be? 2. So if I had one like this, what could I do to this? Excuse me, 1. So if I had one like this, what could I do to this row to make it into row echelon form? Divide this row by 2, right? And then it would be in row echelon form. That's all I'd have to do. Is this one in row echelon form? Yeah, okay. Now as far as reduced row echelon form, okay, it has to have up, above and below every one where you have a leading 1, there have to be zeros. So this is not in row echelon form. This is not in row echelon form. Reduced row echelon form, okay? Neither is this, but this one is. See, above the 1 there's 0, and below the 1 there's zeros? And down here, above there's zeros and zeros. Below here, there's just zeros. And it doesn't matter, since this one has a 0 down here. This one is not, and this one is also. So these two are in reduced row echelon form. And what's nice about reduced row echelon form, that directly tells you the answer. So like if this is like x, y, and z, right? That would say that z equals 3 and y equals 1, you see? And x would have to be 0, you see? So that's what's nice about reduced row echelon form, is that you can directly find the answers from that matrix, okay? But that's kind of like 6 more steps to go from this form into that form. So whether you want to do that or not, that's up to you. We're not going to make you do it, but that's called I'll show you what it's called. Okay, I forgot what it's called, to tell you the truth. So anyway, where are we?
Wait, Mr. Ritter, is this on the quiz?
What?
This is what we're looking at.
No, this is not on the quiz tomorrow. Okay?
What are the sections?
7-1 through 7-3. I told you tomorrow. Come on! Get me! Get! Okay. That's what my high school football coach used to say. He said, "Leader, you killed me!" Okay. Okay, so we're continuing on here. So this is what we're going to do with this next example here, okay, is I don't know how you put that in front, but Gaussian elimination with back substitution. This is how we're going to learn to solve systems of equations. And what you do, when you do this, you write the augmented matrix, which you can come up with from a linear equation. And then you're going to use elementary row operations to rewrite the augmented matrix in row echelon form, which is what we just did. And then write the system of linear equations corresponding to the matrix in row echelon form and use back substitution to find the solution. So that's what we're going to do. Just to show you, I'm not sure exactly why I put this here. It should come later. Okay? But if you end up with a row 0, 0, 0 equals something, that means that there's no solution, because if you perform a bunch of these operations to go from here to here to here to here, we're going to go through one of these. But if you get 0, 0, 0 equals -2, that means that x plus, or 0 plus 0, or 0x plus 0y plus 0z equals -2. In other words, 0 equals -2, which means there's no solution to that,
I just said it
to
should be
that
the last
system.
row of all zeros.
If it's the last row is all zeros, yeah, all zeros. So this is not a 0 over here. See, the -2 is not here.
Oh,
If
like
everything
constant.
is a 0,
Okay.
yeah. So I have a constant on there.
But that doesn't
You
matter
almost-
where that goes, or just the bottom.
Yeah, it doesn't really, I mean, just if you end up with something like this, that means that there's no solution. We have 3 zeros equals a constant, then here it means you have no solution. Okay? All right, so going on to the next thing, now we're going to actually do one. All right? Solve the system of equations. So, first thing I'm going to do is write the augmented matrix. So if I could do, maybe I'm better. No, I think I'm better. I don't know where I stand with this. I wish I had I'm getting to where I'm going to get a tablet that I can look at and do this. Wouldn't that be good? 0, 1, 1, -2, -3. We're going to put a dotted line over here. Okay, so I'm rewriting this as an augmented matrix. Then I'm going to go 1, 2, -1, 0, 2. Yes, Warren. Okay. Then I'm going to go 2, 4, 1, -3, and -2. And then I'm going to go 1, -4, -7, -1, and -19. And there's my augmented matrix. Okay? So what I'm trying to do is get, like, I need to, at the very least, have a 1 up here, okay? And then maybe a 1 here, and then maybe a 1 here, and then something else here. It doesn't really matter what's down here, because then you'll be kind of done. But if I put a 1 here, if I started with 1 here, and then I put a 1 here, and then I put a 1 here, I wouldn't be able to get it into reduced into echelon row form, okay? So I start by trying to get a 1 up here. There's an easy way to get a 1 up here. What would be an easy way to get a 1 up there? Good. I'm going to switch these 2 rows around. Okay, so you want to start by getting a 1 up in that top one. So I'm going to rewrite this, okay, with the top row up here, or 1, I'm just going to move that. You can see what a pain in the neck this is, right? That's why they invented computers, because computers can do this stuff super fast. And -2, tell me if I mess up, because I mess up sometimes. -3, 2, I lost my voice by talking like Coach Nugent. -2, 1, -4, -7, -1, and -19. And so what I did is I switched R1 to R2. I just kind of flipped them, right? Now, what you want to do when you're working on this, you want to get, this has to be, you have to get all zeros in this column. Okay, so that's your next step, is to try to put all zeros. So the kind of the process, first you start with a 1 up here in the first one, and then you want to get all zeros in this column. Then you're going to get a 1 in the next column, and you're going to try to get all zeros below that. Okay, and then I'm going to try to get a 1 over here and zeros below that. And after that, it doesn't really matter what you get down here. Okay. So how can I get a 0 over to here? How can I turn this 2 into a 0? What could I do? Multiply by, yeah, you're not really allowed, you have to multiply by a non-zero constant, remember? So what could I multiply to turn this 2 into 0?
You can subtract. Can you do that?
Can I what?
Subtract.
You can subtract, or it's same as multiplying the what? You can multiply this one by -2, but I'm just going to multiply the top one by -2. So I'm going to take -2 times row 1
So that just be -4
plus
in the first place.
times row 1 plus row 3. Okay? Over here, and I'm going to do 2 things at the same time. What can I do to make this into a 0? Yeah, negative row 1, good, plus row 4, and that's going to turn this into a 0 and that into 0. See? Yes? Okay, so we're going to do that. So this is going to be equal to, here we go. So the first one's, what? It's just an hour per problem, yeah. No, when I'm not explaining it, it doesn't take as long. Okay. And then this one stays 0, 1, 1, -2, and -3. And then this one's going to be -2 times this plus this, which is 0. -2 times times positive 2 is -2 plus 4 gives you what? That gives you 0 there too, which is kind of nice. Okay. -2 times this is positive 2 plus 1 gives you 3. Tell me if I make a mistake, because it's easy to make mistakes. -2 times this is 0 plus this makes -3, right? And -2 times this is -4 plus -2 makes -6. Okay? Now I'm going to do this. This one's easier. I'm just basically subtracting this one from this one. So -1 plus this gives you 0. -1 times this is -2 plus -4, I think gives you -6. This is looking familiar to the last class. Then, did I do that right? -1 times this is +1 plus -7 also makes -6, right? -1 times 0 is 0 plus -1 makes -1. And -1 times 2 makes -2 plus 19 makes -21, right? Yes? Augmented matrix. Okay. Now, all you have to do is turn this into a 0 now. That's not too hard. What? Not yet. We're going to wait. Okay? But so, yeah, you want to work with the column, each column first, and then you do worry about the rows. Okay? So let's turn this 6, because you got to have zeros below. Otherwise, because then we could just divide things to make those into ones. You see what I'm saying? So then work with this one. What can I do to turn this?
Plus 6 by row 2.
6 times row 2. Why wouldn't I want to multiply 3 times row 1?
Because there wouldn't be a 0.
Yeah, because then there wouldn't be a 0 there anymore, right? You understand that? Right? So it might, because the last guy said, oh, I'm going to multiply this by 3, and that would be a 6, and then I can just add them. Right? But then this would turn into a 1, and I don't want a 1 then. You see? Okay? So,
Why would it turn to 1?
because if I it would turn into a 3. Yeah.
There you go.
Okay, there you go. So I got to multiply this by 6. Okay? So I'm going to go row, let's do different color. Row, over here. I'm going to do row 2 times 6 plus row 4, right? Row 2 times 6 plus row 4 to get this bottom row. So now I'm going to rewrite. Okay? And I'm going to leave 1, 2, -1, 0, 2, 0, 1, 1, -2, -3, 0, 0, 3, -3, -6. Now I'm going to do my thing, okay? Row 2 times 0 plus 0 makes 0, right? Row 2 times -6 times positive 6 is 6 plus -6 makes 0, okay? Row 2 times 6 is 6. Wait, did I mess up? Oh, that also gives me a 0 there, doesn't it? Okay. And times 6 is -12 plus -1 makes -13. And 1 goes over here.
-39.
Good, -39. Okay. And now, I still want a 1 here, and I want a 1 here, and then I'm done. But that's pretty easy to do. How can I turn this into a 1? yes, divide this row by 3. And also I'm going to divide this row. Look at how nice, what can I divide this by? 13, right? Negative 13, right? Divide by negative 13. And then I have, okay, 1, 2, negative 1, 0, and 2. And I have 0, 1, 1, negative 2, and negative 3. And then I have 0, 0, 1, negative 1, negative 2. Right? Did I do that right? No, that should be positive 1. No, that's right. Negative 1. Let me make sure. Right? Negative 2. And here I have 0, 0, 0, 1, and what? 3. Positive 3, because I'm dividing by negative 13. And now it's in row echelon form. Okay? Because all the leading numbers are 1, and it's echelon down like this. Everything in front of the 1s are 0s. Okay? They don't have to be 0s behind the 1s. It's not in reduced row echelon form, it's just in row echelon form. You get it? If I wanted to put it into reduced echelon form, I would have to like change this into a 0 and change this into a 0, which I could do, but it's a bunch more steps. Like I can multiply this row by negative 1 and add it to this one by positive 1 and add it to this one, add it to this. You understand that, guys? Hey. So now you're not done yet because you have to solve this system. So if you remember the original system, for some reason they call this, I'm going to go down, okay? For some reason they call this X, this Y, this Z, and this W. I guess because we're used to going X, Y, Z, W in my opinion should go first, right? W, X, Y, Z, but anyway. And this is fine. So what you know is that W equals what? W, no, 1W, that's the coefficient of W, equals 3, right? So we know W equals 3. Okay? I also know that Z minus W equals negative 2. Z minus W equals negative 2. So I can take that and put it in there, and I get Z minus 3 equals negative 2. Z equals 1. Right? I also know that Y plus Z minus 2W equals what? Negative 3. Okay? And so I'm going to plug in for W. I'm going to plug in 3 there. I'm going to plug in 1 there. And I can solve that for Y. So I get Y plus 1 minus 6 equals negative 3. Y equals, what's that? 3 minus 1, 2. Is that right? I think that's right. 3 minus 1 is 2. Y is equal to 2. So far I have 3. And then my last thing is going to look like X plus 2Y minus Z equals 2, because W is 0, right? And this one, or 0W, equals 2. And I still haven't found X yet, so now I'm going to find X by plugging in 2 in there and plugging in 1 in there. And I get X plus 2 minus 1, oh, plus 4, right? Plus 4 minus 1 equals 2. I get X equals negative 1? Negative 1, okay? So I found X, I found Y, I found Z, and I found W. And then I solved my system, okay? So, let's see, that only took 20. So anyway, I just want to show you a couple more things, and then we'll be done, okay? So, I talked about Gauss-Jordan elimination a little bit, and that's Gauss-Jordan, they're two mathematician guys, and what that does is once you get this into this form, which you could solve using back substitution like I just told you, Gauss-Jordan involves changing this into a 0, so you'd have to do an operation on that to get that into 0, and changing these two things into 0. And once I have that, and these constants of course would change, right? But then if I got that, I could say, well, if this is x, y, and z, then z equals this, y equals this, and x equals that. So you eliminate that step of having to plug back into those equations if you did. So you're allowed to do it that way. One in your homework says do it this way. If you want to do it that way, do it that way. If you don't want to do it that way, don't worry about it. Okay? And I think that's about it. Okay? And now I'm going to show you your homework. Okay? Which is, where's your homework? Your homework is on my Cutting Edge website. Index. There it is. Pre-calc homework. Where is it? Pre-calc assignments. Chapter 7. There it is. Oh! I put this in there. Look, aren't I good? I wanted to show you that. So 1, 2, 8, 2, 29, every third. So these ones, you know, it's not that difficult. It just says, say whether this is in row echelon form or not in row echelon form. It's like if these problems over here, you actually have to do something, okay? But these ones should be pretty, the first, like, up to 54, I think, are pretty easy. And over these, you actually have to do, it's not all that long, okay? And then on Sunday, you're going to do this, okay? Yay! Okay.
Let's go back to
Okay.
Yeah, can you go practice?
Okay, there you go. That's the assignment right there. Okay, so we're done. I'll check your homework. I'm done talking, and I